Welcome, guys, to my talk. I'm from a company called Att&ck, and here to talk about security for your Mac environment. Hopefully, you'll walk away with what we call the 5-minute management system for Macs, yeah? A fleet of Macs, anyway. I'm Milan Shah. I'm the Att&ck's co-founder and CTO. And my contact information, I guess. Get started there. And what I'm going to talk about, cover is, as I mentioned, our system, which we sort of developed with our customers. What they were really looking for is everybody's busy. They want to be secure, but they don't want to necessarily, spend their life being security unless, you are a very large organization type of thing. Even there, you want a way where you can constantly keep an eye on what's going on, especially in your Mac environments. I'm going to talk about, break that down into what that really means. Yeah, so I'm going to talk about the health report. I'm going to talk about keeping eyes on critical assets in your Mac environment. I'm going to talk about what it takes to deploy a system that allows you to become the 5-minute Mac manager. Then I'm going to spend a little bit of time. I think there's been a couple of other talks on osquery. Yeah, how many here have already attended a talk on osquery? Show of hands. Yeah, oh, quite a few. Yeah, okay. So I won't spend too much time on there, but just so you know what one of the secret sauce, I guess, underneath the covers is here. Then I'll talk about what is often missed, especially in the world of osquery, is sort of the other half of the puzzle and so on. If time allows, our product is really focused on a wider ecosystem, not just on the Macs. So we focus on what we call the modern environment or companies, right? So people are using Macs in big numbers for their personal productivity platform, and whatever they're building and working on is usually offered through some kind of a cloud environment, right? So a very typical modern enterprise or education system is often comprised of a bunch of Linux servers serving out the whatever was authored and Mac for the authoring environment. So we protect the whole gamut. So if time permits, I'll cover sort of the wider range. Any interest, or should I just keep it on the Mac side of things? Show of interest in terms of go wider versus Mac? Wider? Wider's good. Okay. All right. So I'll talk about that then. Hopefully time will allow that. Yeah. All right. So with that, 5 minutes. So I did struggle with this talk because I truly wanted to this audience to walk away convinced that it takes 5 minutes a day to manage your Mac environment, but somehow I have to use 75 minutes to explain that. That sort of okay. So I'll try to. I'll try to make it worth your while, though, yeah? Give you what the building blocks underneath were. So 5-minute Mac manager, what is this? What are we hearing from our customers, from our prospects, and so on? So what we're really hearing is they want to come in, right? And typically come in the morning, take one look at a screen someplace, and understand where in the world all their Macs are, right? That itself is an interesting problem, especially in this day and age of remote users and things like that. And then more importantly, they want to know, is there anything suspicious going on within their environment that warrants their attention? And if not, then they are busy, they want to go do their day jobs. If there is something that is worthy of their attention, then they want to assign it to a ticket to somebody and try to look into it and take care of the issue and so on and so forth. Yeah. So all you really need to do is figure out where your Macs are, figure out if there's anything suspicious going on. If there's nothing suspicious going on, go on, do your day job. You want to put an alarm on all your critical stuff so that if any clown comes in and tries to modify something during the day, you'll get notified type of stuff. You want to be able to take your normal precautions, make sure that the precautions have been taken, and that's really just about it, right? That should do the trick for the most part. And that's what I'll talk about, right? So our answer to that is a solution which looks something like this, yeah? So we call this our Mac EDR dashboard. So as you can see, we have in this case, I've got about 7 Macs in this particular demo environment. It tells you first and foremost where these Macs are actually logging in from. And more importantly, it tries to tell you whether anything suspicious is going on your Macs, right? Now, again, this has been culled together by working with a lot of people who do this for a living. And they boil together. Right now, we have these 6. We are working on a few more indicators of compromise. So these things are called indicators of compromise. Show of hands, people familiar with the term indicators of compromise? Yeah. So indicators of compromise is basically something going on the machine that may indicate that there's something suspicious going on. Yeah, usually there's no silver bullet. There's no, oh yeah, definitely, your best friend from North Korea is on your machine today. That just doesn't. There is no such indicator. Yeah. And they are too smart for that. So the best you can do is come close, yeah? So things like, well, if you had a database of known bad IP addresses, which of course changes on a daily basis or hourly basis, I should say, right? But if you had a database and you were able to somehow magically figure out if any of your machines are connected to any one of them, well, that would be an indicator of compromise, right? If critical files are being modified, yeah? Well, that could be potentially. Why are we modifying critical system files on an operating system? If the location of a machine has suddenly changed, yeah? That could be, yeah? It could be a lost laptop, could be somebody traveling on business, yeah? Large network I/O or OS X malware being discovered on your machine, or just plain old software, kernel extension, something like that being installed on your machine. These are all indicators of suspicious activity. But as you can probably gather, yeah, any one of these things tends to be very noisy. So even in my demo environment, you can see that over the last 7 days, this machine over here has fired like 14,000 alerts, right? So, or close to 15,000 alerts, yeah? It's literally impossible to try and look into that kind of a noisy signal type of thing. So any one indicator of compromise tends to be very, very noisy. Critical files being modified. Well, that's just auto update doing its thing. Well, it had to, it modified critical files, right? Locations being changed. People traveled on business. Large network I/O. Somebody's traveling on business, downloaded a Netflix movie, et cetera, right? So if you start chasing these signals down, every single one of them, yeah, you're not going to get to your day job, right? So what this panel is trying to do, though, is trying to see if multiple ones of these indicators are happening in conjunction. If somebody accessed a bad IP and modified a critical file and changed locations, and there was a suspicious login, et cetera, right? That starts painting a suspicious picture. Yeah. So that's what this panel is really trying to do. Okay. So the whole basic idea is you should be able to come in over here, take one quick look, see if any of the machines are bubbling up and showing any multiple indicators of compromise, and then be able to investigate. And I'll talk about how you go about investigating. But this is your 5-minute view in the morning, right? Very quickly assess the state or the trustworthy state of your machines. Yeah. The rest of the talk, I'll talk about how we actually manufacture this data and these signals and so on, so you get more insight into how you can tune it and control it and so on and so forth. But this is what our customers are using today to figure out, aha, I see, yeah, I'm keeping an eye on it, and if something bad's going to happen, I'm going to get an alert. So things are under control. Now we can all go do what we are paid to do. Yeah. So what you just saw is, to repeat again, right? Look for physical location. Why is that important? You want to look for changes of locations. You want to look for things coming in from sanctioned countries and things along those lines, right? And you want to have alarms and alerts set up in case some of these events do happen. Yeah. And as I explained, indicators of compromise. What's interesting is that yes, they are noisy, but when you see them as a group happening together, that's your usual indication to say now you want to take a look at it, right? If any one or two of them firing 10,000 bad IP accesses, just some over aggressive script kiddie out there trying to break in and not getting anywhere, yeah? So, but when multiple ones of them start happening, that's your real indication that, okay, something bad is about to happen over here. What do you do to protect against this kind of stuff, right? So you start by taking some common sense precautions, right? So there's these 8 things that have been identified, right? I think people in the Mac, all of you guys, I should say, yeah, probably are very familiar with this, all of this stuff, but I don't know if it makes sense for me to read them all out, right? But you want to enable things like gatekeeper. You want to enable things like stealth mode, which is a feature of the firewall. People know about stealth mode? Yeah, okay. So I guess the couple of things I'll point out is remote logins. That, again, just from our customer experiences, we'll see people who enable that. You're basically enabling SSH access and SFTP support. And those two things are going to attract a lot of remote attacks. Yeah? So there's lots and lots of automated agents that are just literally roaming the network, the entire internet, scanning the entire internet IP address space, trying to see if any of the common misconfigurations of SSH are available on your machine. And then if they break in, then, well, they have access to an extra machine type of thing. Yeah, so that's something you really do want to disable or enable it, only when you actually need to do something along those lines. Yeah, so that's a very common thing that we see over here as we go through our customer deployments and so on. Yeah. Now the challenge that we see in many of the environments that we're in is how do you keep track of, how do you even know you're managing 1,000 Macs or 500 Macs, something along those lines, right? And how do you know that everybody is following this policy? And more importantly, how do you know that, so maybe you deploy it, maybe when you deployed it, you took all these precautions and you deployed your machines properly configured, but then somebody came in and, changed something along those lines, right? Somebody came in and or enabled remote logins and so on. So you want to be notified when something like that happens, yeah? So, our solution helps you with that. So we have actually enough information in our product where we can pull a report for you, a report that might look something like this, yeah? So this thing has actually gone out and queried some, my demo environment in this case, yeah? And discovered that, well, I have 7 machines online, nobody's offline at the current time. And it ran these checks, yeah? And as you can see, what happened is it checked to see if application firewall is turned on. It checks to see firewall status and so on and so forth, yeah. Remote login status, yeah. Remote login, as you can see, is enabled on those 5 machines, yeah. That's why they're attracting those 15,000 types of alerts. So, common response for something like this would be to turn off remote logins on those. Now, those 5 machines happen to be on a hosting, I'm using them in a hosting center, host my Mac basically facility. So there's no way for me to turn that off, because without that I don't even have access to that. Yeah. So that's why those machines are in that particular state. Yeah. But that just means I have to keep a sharper eye on the rest of the indicators, because I know the bad IP access is going to be a noisy indicator for me. So if it suddenly starts doing, those machines start doing large network IOs or have a remote login or something along those lines, that's when I'll start paying some attention to it. Yeah. So any case, so our product can actually go in and pull a report like this for you, and very quickly tell you where you stand with respect to the health of all of your Macs. Yeah. So again, 8 settings, not too difficult to really make happen, at least to start with, yeah. But the challenge then becomes in continuing to maintain and checking in on the posture and making sure that you are notified when something deviates away from that posture, right? So that's where we would consider setting up an alert for something like this, and I'll talk about alerting and so on that comes from our system that allows you to continuously monitor and make sure that you are maintaining the posture that you really want to, yeah. Now starts coming the interesting part of the security side of things, yeah. So people familiar with the Att&ck framework from MITRE? Okay, okay, some people are. Excellent, yeah. So what it stands for is Adversarial Tactics, Technology and Common Knowledge. I think it's a made-up thing just for the acronym. A lot of us know it as TTPs, Tools, Techniques, and Practices, yeah. It's published by MITRE, and it's a pretty comprehensive chart of tools, tactics, technologies being used by the attackers, yeah. And it gives you some sense as to how you might actually be able to make a dent in securing your environment. So the Att&ck framework, they've published one for Mac, one for Windows, one for Linux, right? And what they've really done, can you read this? I can barely read it. Okay, so yeah, there's going to be a test, and actually I should have mentioned people who pass the test, get a special gift type of thing. So you may want to pay as much attention as you can, yeah? But what they've really done is broken attacks down into the different phases. Now, this is one of the problems that I can actually send you a link if you want as well. If you just search for Att&ck Framework with the &CK, you'll find the MITRE link, and you'll have this full chart over here, yeah? But the most important well, a couple of things here, yeah? When attackers work, they work in phases. It's not like they go in, they attack one vulnerability, and suddenly they're at the crown jewels, and the next thing they know is they are, selling your amazing database in Brazil for $3 per row, right? That doesn't work that way, yeah. So they have to do a various numbers of things, yeah. They have to find a way in. They have to, and this is going to be important. This is why I highlighted it. They have to persist the initial breach, yeah. So if they are able to find a compromise, break into one of your machines, the first thing they'll try to do is figure out how to persist it so that they can continue to access your machine on a long-term basis. And the reason they need to do that is because after they break in, they need to do other things. They need to figure out a way to escalate their privilege. Usually when you break in, even if through a browser or something like that, you're still limited to the privileges that the user account that the browser started. That's not usually enough to do real damage. So people will try to do some privilege escalation. They will have to discover what else is around your machines. They will try to do a lateral movement to find, ultimately find and compromise those machines as well, ultimately find the crown jewels and so on. So it's a long process, and it takes time for the bad guys. And they can't hurry it up either, because if they try to, the likelihood of discovery becomes higher, right? And at the end of the day, they are running a business, right? So that's an important thing to keep in mind. And every time they have an attack that fails, that just costs them money, right? So they are going to go low and slow, and that gives us an opportunity to do something about it before real damage can be done, yeah? So our recommendation is to focus in on the persistence layer, right? So every time they breach a machine, they're going to try and persist that breach. They're going to put something that no matter how many times you reboot, et cetera, or God forbid even, run antivirus and so on and so forth, it will escape detection, right? So they will try to do something to change the state of your machine in such a way that they can keep coming back in once they've compromised it without relying on the original vulnerability and so on and so forth, yeah? So what that really means from our perspective is that what we have done is taken the entire attack framework and tried to map them into things that will change on your system if somebody was trying to persist. So it's just a snapshot of it, yeah? On the right-hand side, you can see we have taken each of those rows, and we have figured out, saying, okay, for example, a bash RC or configuration file, right? That could be a common way for somebody to modify so that every time you spin up a bash, you're actually spinning up, some malware that you didn't even know was already infected type of thing. So what do? Well, you modify changes to etc bash RC or, user bash RC and so on and so forth, yeah? And on and on and on, right? So launch daemons, launch agents, those are other things which are specific to the Mac, right? That's a common way to start a process up when the machine boots and so on. So you want to monitor those directories and all that, right? So it's not rocket science. You can take the attack framework yourself. You can figure out, which directories or which files, etc., will likely be modified if something like this, somebody was trying to do something along those lines, yeah? Or you could just, rely on a solution like Att&ck, which will come along and actually set up those file monitors for you, right? So if I skip out of here, go back to my demo environment here. So if I go to my configuration over here, and if I take a look at file monitoring, what you'll see, Att&ck comes with the MacAdmins framework already built in. So all those files are being, all those locations, those directories, et cetera, are being monitored for you. And that's what's powering part of the hey critical file being modified alarm for you, yeah? So now if you used Att&ck in this manner and configured it properly, you would be able to monitor your files and have really good indication if any of these attacks are actually happening in your environment. Okay, and go back over here. So that critical file being modified is actually being powered by that list of directories that we actually monitor over there. Yeah. Okay. Any questions about the attack framework? So basically, you can study what the attackers are actually doing, or MITRE has studied it and documented it, and then we can use that information to try and catch attackers as they are making progress within your environment. Yeah, file monitoring is a very effective way to try and do something like this. Yeah. Now it's getting a little complicated, right? So I'm sure you're thinking, okay, you kind of like that nice little map with all those indicators already wired up and everything and so on and so forth. So what does it actually take to get to that stage where your environment is actually being reflected in a dashboard like that? Yeah. So, well, it turns out, yes, it can be cumbersome. So if you start with plain old osquery, so that's part of the secret here, that we use osquery as the agent that's actually running on the system, right? It's open source. You can do it yourself. And you can certainly, Att&ck Framework is, again, not proprietary. It's from our taxpayer dollars. So you're welcome to do all the mapping and so on. If you try to do it all yourself, it can be a chunk of work. At least it turned out to be a chunk of work for us. But the good news is, it's an engineering problem, really speaking, right? So once you solve it engineering-wise, you just package it up and make it available to everybody else, right? So that's pretty much what we have done. So what I'm going to do is now switch over to a different demo system so that I can show you how you can start from a standing stop and get to a point where that MacEDR dashboard is populated, yeah? So we are Att&ck's fastest way to deploy osquery at scale. And then once it's deployed, we automatically, out of the box, we make that kind of a dashboard available, right? So the first big benefit to Att&ck's is that we are a SaaS solution, 100% SaaS. So there's nothing for you to install, nothing for you to configure, no machines to provision, et cetera, et cetera. You come to us, within 15 minutes, you'll have an account set up for you. You log in using your Google ID or your corporate ID most of the time. They are usually Google App enabled. And something didn't go right here. Apologize, let me. Apologize, I thought the system was cleaned up. Interesting. Try that one more time. I think the problem was I was logged in with the wrong account. All right, so you log in using your Google ID. So apparently that's a difficult thing to do. All right, there you go. We'll welcome you, prompt you to get started, right? And all you do is you download the right version of osquery for your environment. So in my case, it's I'm running OS X in my environment, so that's what I'm going to download, right? Now what's coming down is just the pure old common, the open source version of osquery, right? So we ourselves have an osquery engineering team. Everything we do to osquery to make our product work better, we contributed right back to the community. So there is nothing proprietary coming down with this package that I'm just downloading, right? Now this PKG file does have a couple of things added to it. So in addition to the open source osquery, we have enough secrets and certificates and configuration files bundled with it. So when you install this PKG file using Casper Jamf or just double clicking on it type of thing, yeah, it will automatically connect up to Att&ck's in a secure, authenticated manner. So as a matter of fact, what I'm going to do now that it's downloaded, I'm going to, in my case, I'm going to use Ansible to deploy use Ansible to deploy my PKG file to all of my Macs. Yeah. It's going to take all of 2.5 seconds. Yeah. It actually went that fast. And in that amount of time, what actually happened is osquery got installed on all of those machines. They woke up and they connected up to Att&ck's in a secure, authenticated manner. And at this point, you're done. So a typical customer for us has anywhere from, on the very low end, 50 machines. Typical customer is in the multiple thousands of machines, Macs as well as whatever they have on the cloud and so on and so forth. Yeah, they can usually be in production in under 15 minutes. So at this point, that's all that the deployment and configuration was required. You download one PKG file, one deb file, one RPM file, whatever makes sense for your environment. You deploy it to all your endpoints, and that's it. Okay, that's it. It connects up to Att&ck's cloud, and all those file monitors, all those reports, all those things have been enabled for you, and they can start working at this point in time. Okay, so try to make it simpler, I guess. So as I mentioned, it's supposed to be the right agent. I am now going to talk a little bit about osquery, but that's basically what we deployed over there. And that's really all there is to it. It's sending a whole bunch of data. osquery, as you'll see, big trick to using it right is to figure out what to ask it, and what kind of data to collect from it. So I'll talk about that next and so on. The cloud auto-configures osquery and starts collecting the data, and at this point powers all the rest of the functionality that we have. Yeah. So osquery, I'll make it very brief. Yeah, it's to me it's one of those DOE moments, right? I guess I spent the early part of my career at Microsoft. We did do a WMI. It does have kind of like the SQL interface and so on and so forth. But there were some important things that were not right about that particular implementation, at least in my opinion. Yeah. One of them was WMI is a server-side technology. If you're anybody familiar with WMI, yeah. So it's in some ways. Similar to osquery, but an important difference, it's a server thing. So you have to connect to the Windows box, and then you can present SQL queries, yeah? Well, how are you going to connect to a Windows box across firewalls and things like that, and VPNs and so on and so forth? That's a big problem, not to mention you now need admin access to all of your Windows boxes, right? osquery does it right. It doesn't connect, it doesn't receive connections inbound, it connects outbound, okay? So, and it presents all system data in terms of SQL databases, yeah? So this is another important thing. So there's tons and tons of security solutions out there, Carbon Black, CrowdStrike, Cylance, et cetera, et cetera, et cetera. They all have an agent. They all have, a proprietary way of transmitting data and so on. And they, that's a big part of their IP. They spend a lot of energy trying to optimize just the data required for their functionality. And then as soon as they do that, the attackers come in and they come up with some new technology, and suddenly that data is not available, and now you have to wait for a rev of the underlying system. osquery flipped the whole thing on its head. It said, look, we're not going to be purpose-built for any one person, any one thing, yeah? We're just going to be really, really efficient at exposing data about the system, all data, right? And the aha moment was, if you're talking about data, well, how do you do data processing? Well, you do data processing using relational algebra. It's been known since pretty much the dawn of computing time, right? It's called SQL. So let's build a system that basically allows you to access all system data as a bunch of normalized SQL table or pseudo-normalized SQL tables, so on. Yeah. So that's what osquery really does. Yeah. And just to give you a quick flavor of that, for those of you that haven't been to a osquery session, I'll use a couple examples. So this was, in some ways, the original inspiration of why osquery was built. So let's say, traditional ways of getting at data require ultimately for you to use some tools that come bundled with the system, right? So as an example, let's say I want to know uptime, on the system. Well, every system, including Macs, have a tool called uptime, right? And that'll tell you uptime, and here's the output of uptime. Can you see it? Okay. I'll try it again. See it better now, a little bit? Yeah, it's cryptic output. It's all text and so on. and it's going to tell you about when it started. It's going to tell you that it's been up for 10 days, 13 hours, 49 minutes. It's going to tell you something about users. It's going to tell you something about load averages, and so on and so forth. Yeah. So if all you really want is just tell me how long, how many minutes, or how many seconds, or how many hours, days, etc., this thing has been up for, you basically have to write some small amount of scripting code to take this output and massage it into the one number that you want, right? Or you're like me and you want to know something about processes on this system, right? So, well, PS will tell you what processes are. Well, that's more than that process is running. So now I have to remember that, oh yeah, I have to do -e to figure out all the processes, right, regardless of who started them. And then suppose I want to know the name of the process, yeah? So here's one of the test questions, I guess, right? Anybody remember, I can get the PID by typing in, I guess, -o PID. Anybody know how to get the name of a process from the PS command? Yeah, it's sorry? Yeah. Sorry? Oh, -ef and grep? That's still. Oh, all right, fine. So everybody either has their favorite tools, or if you're like me, you do a man page, you do Google, you do blah, blah, blah. Yeah. Turns out it's UCOM. Yeah, user command, I guess. Yeah. All right. So if you know, you spend 5 minutes, you get along with that, right? Let's say you want to know something about configuration of these machines, right? So we all know about plist files and so on and so forth. So let's say I want to know something about how the power management has been set up, right? Now, of course, that changes every single bloody version of my OS X. Yeah, changes the location, changes the file format, and so on. It's in a plist file. It's all XML, so I should be able to at least get at it. Yep. Oh, well, I guess not. On my machine, it's a binary file. Great, right? If I can type, yeah? All right, we'll try another one then. Yeah. The time zone plist. This one is an XML, yeah? So, but you see the problem, right? It's sometimes binary, sometimes XML. Now there's a tool to convert from binary. And all you're trying to do is learn something about the configuration of your machine, right? So this is really the inspiration for osquery. So they said this is just, getting old, having to spend 5 minutes every time I want one piece of information about the machine. It gets really old very fast, as you can see, right? So osquery really solves that problem, right? So so if you use osquery, it basically presents all data available from the system available as normal database tables, right? So what I can do is I can start using standard SQL, right? So for example, I can say, select start from uptime, start typing in the uptime command, and what comes back is a database table with all the data that I needed in a nice database format, yeah? If I want processes, right, well, I can just, I don't have to worry about another 5 minutes spent that I'll never get back. I can just use processes as another database table, and I can just say, PID comma name from processes, and back comes the process ID and the name from the processes table, and so on. Yeah, or I can go, select start from preferences, where domain like percent time zone percent, and get the same information that was in an XML file, yeah? So the value really over here is that no matter what information you're looking for, you're just typing SQL, you're just getting everything back in standardized database format. So now you can take the entire power of the SQL ecosystem and be able to manipulate this data for whatever analysis that you are looking for, yeah? Two important limitations, though, as you can see from here. First of all, Facebook open sourced this, so that's just a wonderful thing for them to have done. It's become the #1 security project in GitHub in just the 2 years that it's been out there. Yeah, attracted over 250 developers. Really a fantastic way. So pretty much any information that you're looking for about the system is available in osquery today. Yeah, fantastic job over there. Yeah. Two big limitations, out of the box, osquery, as you can see, is a piece of software that runs on a single machine. So if you want to deploy it at scale and then connect it all up to a centralized system, you need something like an Att&ck or some solution like that to make it happen. The other thing, which is, comes as a surprise, is that it doesn't out of the box start running those magic queries and then starts telling you that box over there, that's the one under attack. In fact, it actually does nothing. Okay, it just waits for you to ask the SQL queries. It waits for you to take the data. It waits for you to analyze it, and so on and so forth. So that's what really Att&ck does for a living. Is we deploy osquery at scale for you. We are the ones that have this, we have developed a set of queries that allows us to do the entire intrusion detection, file integrity monitoring, as you saw in the earlier part of the demos. That's what we deploy automatically, and we're collecting data and giving you that functionality out of the box, yeah? All right, so a few other pieces of tidbit might be interesting. As I mentioned, universal means it's not purpose-built. osquery data is powerful, especially if you retrieve it continuously and store it like we do. We had somebody come into our booth and they wanted to figure out, can you get a report on the usage of software, how many hours of the day are people using Excel or Word or PowerPoint, that kind of stuff, and so on and so forth, right? Now that's not a solution, that's not a problem that any vendor would specifically target, yeah? So, I mean, is it a security thing? Is it an MDM thing? You'd probably have to go and do a rev of whatever product is out there. But with osquery, all that kind of data is available. They didn't really solve that particular problem. They just said, look, it's data available from the system, so we'll just send it to you, right? Or if you ask for it. We at Att&ck, we ask for pretty much everything that allows us to recreate the full state of the machines. So we continuously get this kind of data. We're storing it in a historical store, and that's what allows us to answer those kinds of questions, even though we didn't sort of set out starting to solve those kinds of problems. Yeah, it's already very widely deployed. I'm very surprised when I run into, I can't name some of these names. These names I've named because they have given talks about their osquery usage. So you can deduce, but it's widely deployed at Adobe, over 100,000 nodes, Airbnb, Uber, Palantir. They're all big users of Palantir, of osquery, and so on. So it seems like a really good bet to make. It's still early days, somewhat early days in the world of osquery, but in terms of a security monitoring solution for your Mac environment, a very decent bet to make in terms of running on your Macs, or just generally in your environment. Yeah, as I mentioned, two big limitations. It's how do you do this at scale? That's something that's been left for vendors like us, or if you want to do it yourself, you can fix it yourself as well. And it doesn't run a set of magic queries out of the box, so there's a lot of effort going on to try and figure out what the magic queries that need to be run are, right? What we have done is try to solve that problem, right? So as I mentioned, we are actually much broader than the Mac. We support all the platforms. We actually have enhancements to Windows where we can get you equivalency in terms of functionality across all platforms, so Docker, Windows, Mac, Linux, and so on. The first thing we do is, as you saw, we deploy osquery, and then we give you a level of fleet management, right? So we allow you to configure osquery or tweak it if that's what you want to do, yeah? As I mentioned earlier, the bigger thing we do is we provide a cloud service which sends it configuration files and starts asking it questions over a standard HTTPS channel, right? And at the current time, about 1,500 pieces of data continuously being collected over a secure channel, just standard HTTPS. And again, as I importantly mentioned, osquery doesn't accept inbound connections. It's basically connecting to the cloud outbound, just like a browser would. So as long as your machines have browser access, they can run osquery and connect to Att&ck, yeah? Over there, on the cloud side, we provide really 3 levels of functionality. So on the one side, we give you an ability to do Lambda functions. What that means is as data is coming in from osquery, if you want to trigger off of that, somebody just changed their firewall setting or somebody enabled remote logging, that data is coming in. You can install a Lambda function in Att&ck, and you can write that in SQL, you can write that in JavaScript, and you can power an alert out to to Att&ck, or to yourself from there. The other important thing we do is we maintain this historical flight record of all the data that's coming in. This allows us to go back and use the data for threat investigation and so on. So that's another important sort of element. When incidents happen, when you get alerted that something bad might be happening, you're typically not going to be able to respond, drop everything and start running it right away, right? But by the time you start looking into it, the actual incident is obviously in the past, right? So now how do you investigate this incident? So what we do is all this data that we have collected, we have stored it in a big data store and made it accessible to you. And hopefully if I have a little bit of time, I'll be able to show you in more detail how we enable that to happen. Yeah, and then if you actually want to go and touch the machine and figure out what's going on the machine right now, we can give you access to real-time queries as well. Now we take this, as I mentioned earlier, we marry this to threat intelligence data feeds that we have partnered with threat intelligence providers in the industry and integrated their information into our cloud platform. Yeah, so now we can get full visibility of what's going on in your environment from osquery, and then we have threat intelligence feeds that come along, and we can now correlate the two information to now tell you whether we see any indicators of compromise in your environment. Yeah, and then we have added, of course, the standard alerting reporting dashbook, so we give you alerts over email, Slack, PagerDuty, etc. And we have wrapped it all up in a out-of-the-box experience for file integrity monitoring, for EDR, for audit and compliance, for incident investigation, for vulnerability management. Yeah, so these are reports and dashboards that we provide out of the box based on the data that's coming from osquery, based on the threat intelligence and other information that we have coming in from our third-party partners, and what you get is a turnaround and fully integrated solution over there. Yeah. So in terms of showing you a couple of other things. So if I go back to here, sorry, keep doing that. So you can see that what we have done is ingested a whole bunch of threat indicators from a whole bunch of third parties straight into our system, from partners like Proofpoint. We get emerging threats, partners like AlienVault. We get feeds like OTX threats. So over 250 or over 200,000 different indicators of compromise continuously being updated. Right? We also have vulnerability information security advisories coming from all the major distros, from Mac, from Apple, and so on. So all of that data has been ingested into Att&ck and normalized into a standard SQL database, right? So now that we have data from osquery coming in SQL format, we have threat intelligence data been normalized, we can correlate the two, and that's how we are powering information about potential intrusions that we are seeing in your environment. Okay, and that's what ultimately allows us to produce a dashboard that looks like this, yeah? Okay. So just some learnings from the field. In terms of designing the queries. So with osquery, you can design your own query, send it out, and so on. In the real world, what's happened is you have to be very, very careful when you design them for really, commercial use and so on. Why? One of the couple of things that we have seen, right? Not all Macs are made the same. Some were made in 2012, some were made yesterday, that kind of thing. Yeah. A query pack that you have really tested out really well will start, failing on an older Mac because it's taking more CPU or whatever it is, right? Now, osquery has this servo mechanism built in where if it detects itself taking up, beyond a certain amount of memory or CPU, etc., it will actually kill itself and blacklist the query and so on. So if you're not careful, it turns out, you'll end up with dead OS queries all over the place. Yeah. The other element over here is if you start designing a whole bunch of queries, so we do over a couple hundred queries ourselves in order to feed our cloud system over there. yeah, what you'll find out is that you have to now suddenly start, planning when will those queries run, because you have time slots and so on and so forth. osquery doesn't do that for you. You have to tell it how frequently to run these queries and so on. So you start designing the intervals and so on in order to minimize the impact on the endpoint, maximize the amount of data you're getting and so on. Can be done. Well, we did it, yeah. But be careful if you're trying to do it yourself, yeah. We use it to collect the data, and then we do all of the actual heavy lifting on the Att&ck's platform, on the data store, yeah. Another tempting thing to try and do is to actually, because osquery understands SQL, to send all your SQL data, SQL queries over there, yeah. Well, again, for the reasons I just talked about, that often just doesn't work very well. You end up with dead osqueries all over the place, yeah. Now, having said all of that, you can still try and do all of that. The other big part of the problem is the fact that osquery knows everything about your machine. It doesn't know what's going on in the real world. It doesn't have threat intelligence data. It doesn't know what vulnerabilities exist or what the vulnerability database is and so on and so forth. So even if you were able to get the queries onto osquery, you still wouldn't be able to really solve the problem of trying to figure out what's going wrong and so on. So your best bet is to take use osquery as a data collector and then do all the correlations and all the analytics on a backend database. And that's what sort of we do, yeah? So back to the 5-minute Mac manager. What we end up doing is actually quite simple. We keep track of where all your Macs are. We keep track of anything suspicious going on, and hopefully you've got a good flavor of all the kinds of technology we are bringing in to try and help you understand when something suspicious happens. We put an alarm on the critical stuff, all those persistent layer type of stuff, and we help you take your common sense precautions, right? So the whole idea here is, as far as you're concerned, with an Att&ck-like solution, you should be able to come in and be able to deploy this in the order of minutes and suddenly have a dashboard and hopefully sleep a little bit better at night, knowing that there is a good system of security monitoring going on in your environment, yeah? So that was what I came prepared for. I can go and do a broader view of how to do a deeper threat investigation, for example, when an incident happens. I can go ahead and do that. But let me see if there's any questions before I go and do that part of the thing. Yeah? Oh, yeah, sorry. Yeah.
So you mentioned you have vulnerability data coming in to Att&ck.
Yes.
I was wondering, do you feel like you have enough data in there, or soon you'll have enough that this could replace, for people who don't have very specific needs for vulnerability management, vulnerability scanning software? I think you're going to have enough data in there that you can say, well, I don't need whatever of these vendors that I use, because I use osquery for that.
Yeah, actually, that's a really great question, right? So first of all, we don't have enough data to be ASV certified yet, yeah? So if people are familiar with the world of vulnerability scanning, there's a standard called ASV, application certified vendor, I guess. And you need to be ASV certified in order to meet the requirements of PCI DSS compliance. So if you are doing scanning because you have to be PCI compliant, you have to use an ASV certified vendor, which we are not, yeah? But having said that, where we are seeing is a lot of our customers are in fact replacing it. And the real pain point has come in when people are moving workloads to the cloud. The problem with the cloud has been that you can't scan, because cloud machines come up and go down based on software. Machines are spun up based on load, they're spun down based on load going away, etc., right? So that doesn't really jive with, okay, I scan every Friday night at 2 a.m., yeah? So now how do you do vulnerability scanning at all, right? So many of our customers, in fact, are using us because we have the data about what was installed on those machines sitting around in Att&ck, and then we marry it with vulnerability management database. So absolutely, we have many customers who have, for example, replaced Amazon Inspector as an alternative, right? Because it's all, why pay extra for that when it's all included in the Att&ck solution? Yeah. So it's certainly for Linux systems, it's pretty close. Yeah.
All right. Thanks. If there's no one else, I have a second one.
Yeah.
There's been a bunch of stuff coming out in the last few weeks, like Trail of Bits released extensions that let you write to the machines, like to configure firewalls and Santa and all of that. Is that something you're looking at integrating into?
Yes, yes, absolutely. Yeah. So what we are looking at is, in addition to, like I gave an example, right? All these alerts are firing. It's most probably because firewall is not enabled. Wouldn't it be great if you just could hit a button or just automate it, saying, hey, if anybody ever turns off the firewall, turn it back on again, type of thing. Yeah. So we're absolutely working on an extension. Yeah. We have a prototype available that similar extension to what Trail of Bits has that allows us to do that. Yeah.
Thanks.
Yeah.
You mentioned earlier that it was only sending out information from the client side. How from the web do you actually ask for the information that it's sending out?
So the way osquery works, a great question, right? So if I understand the question is, osquery sends us information whenever it feels like it, but if I was asking for additional information, how does that, how do I surface the request, right? So it turns out osquery connects to whatever backend is, in our case, Att&ck, yeah, over at least 5. There's actually 7 different, what they call endpoints, or basically different URLs, right? The one is obvious, which is that, hey, I was told to run these queries on schedule, so here's the answers, here's the answers, here's the answers, right? So that's called the /log endpoint, yeah? The other one it does is it posts a request saying, hey, is there any ad hoc work for me to do? Any real-time queries for me to execute, right? Well, it makes that HTTP request to Att&ck, and Att&ck basically just sits on that request until somebody types in a query. And so it's just an HTTP request that just never comes back until somebody types in a query. And as soon as somebody types in a query, we tell the affected OS query saying, oh yeah, by the way, that request you sent 3 days ago, finally have the answer for that. Here, go ahead and so that from an intuitive level, that's how it works. Of course, there are timeouts and things involved and so on and so forth. But the important thing is it's not constantly polling. It's not just constantly coming in every 3 seconds saying, do you have any work for me? Do you have any work for me? Yeah? It makes it's a very low traffic kind of a implementation. Yeah. Any questions? Interest in going across is the thing. Yeah. So as what I'll do is I'll use the time I have to talk a little bit about how you can use the same solution to actually cover a bigger matrix. How many of you here are a mixed environment, Windows as well as Linux / cloud stuff and so on? So cloud over here, Docker. Okay, all right. So yeah, so that's really the sweet spot for Att&ck. Is what we have done is leverage the fact that osquery exists. osquery exists on all these different platforms, and more importantly, normalizes the data across all the platforms. So the way I ask for uptime on a Mac is the same as on a Windows. It's the same as on a Linux and so on and so forth. So since all that data is coming into Att&ck and our functionality is based on the data that's coming back, all that functionality just starts working and so on. So let me give you a flavor of the kinds of things we can do on a Linux platform. Yeah. So the first thing I'm going to do is actually, I guess I'll go through and download the Unix version or the Linux version of osquery for my environment. So what I'm going to do is use a little cloud environment that I've got up on Azure. So here's a bunch of Linux machines sitting up in the cloud, yeah, on Azure. Happens to be all running Ubuntu 16. So I'm going to come here and I'm going to download the Ubuntu 16 version of the package now, right? And wait for that thing to download. Oh, it's doing that. Okay, now that it's downloaded, I'm going to run Ansible again. This time, slightly different script to deploy it to my to my Linux machines, right? So again, I think sorry. There it goes. This time it's installing the Debian package on all those machines. As you can see, it took a few seconds, 10 seconds this time, a little bit more machines. And what should have happened is in the time it took to do that, now they're all on board here, yeah? So if I take a look at the assets, Atlanta, Baltimore, Boston, Chicago, same ones that I had up over here, Atlanta, Baltimore, Boston, Chicago, and so on and so forth, right? And if you take a look over here, you can see that this was created at 2:23, and it's 2:23 right now. So just take a few seconds, yeah? So once again, to illustrate the point that deploying this Att&ck solution literally takes of the order of minutes. You download one package, put it on your endpoints, you're done, yeah? I'll start by talking a little bit about real-time queries. So you can obviously come in, you can start doing real-time queries. So all of these machines are now in a centralized place. So I showed you how you could do uptime on a single machine. Now I can say, well, go get uptime from all these machines, right? So back to your question about how is this working? What's happening is all these osquery guys are connected to me, waiting for me to type in a query like this. And I can say, go for it. You can see the rate at which the response came back, right? It's pretty fast. Why? Because osquery was already waiting with a request outstanding saying, hey, do you have any work for me to do, yeah? Show you how it works with slightly more data. So all processes across all machines. Boom, here comes the answer, right? So it's pretty fast, pretty snappy because of the way you implemented it, right? Again, to the earlier question, here's processes from Miami, happens to be a Linux machine, right? You can tell it's Linux, it's running systemd. But look at the schema, process ID, name, path, command line, et cetera, And here's the similar answer from MacBook Pro. It's running Mac type processes, launch D, Apple events, etc. But the schema is the same: process ID, name, path, command line, etc. Right? So you can see the value here. Yeah. So now suddenly your entire infrastructure, regardless how disparate it is suddenly sitting in a normalized database. Yeah, which you can query to your heart's content. Yeah. So what I'm going to do to try and illustrate some of the power of this is I'm going to run a little script that creates some real world situation in my environment. So I've written this little script called Havoc. What Havoc does is it simulates, a cryptojacking attack on a couple of my cloud machines. It's going to, basically compromise them and do cryptojacking. Now, I developed this demo about a year and a half ago. Recently, we were actually subjected to one of those attacks ourselves. We had left a demo system with a Postgres database on a Google Cloud environment, and suddenly we got an alarm saying that Postgres was connecting outbound to IP addresses, right? So that's odd, right? Why is a Postgres database connecting outbound? As you'll see, we had enough historical data to track down that, we tracked down where these IP addresses, it was connected to about 96 of them, different IP addresses, all registered to all kinds of different trading companies in Australia and Hong Kong, right? And then the inbound connections, a few hours prior to that, was through a Tor network, unfortunately, right? So we couldn't track down where that the attack originated from. But clearly what had happened is we had left this demo system, Postgres port, exposed to the internet, and so somebody had been able to break in and then use Postgres as the compute engine for cryptojacking. So that's why it's going to do something similar over here. Yeah, it's also going to simulate a couple of real malware attacks on a couple of other machines. Yeah, in the environment. So what's really going on, as I promised earlier, right, is Att&ck has deployed a whole bunch of queries by default. So all I had to do was deploy that package, and then Att&ck started running a whole bunch of queries in the background. Yeah, as you can see, these have been tuned so that the intervals have been tuned so that to minimize the load on the endpoints and to maximize the distribution of when the queries actually run so that not all are trying to run at the same time type of stuff, yeah? So we even out the load and has worked very reasonably well for us, yeah? So that's one of the big value propositions you get out of the box, right? I already talked about the threat sources, all these threat feeds that are coming in. So we have threat feeds coming in, we have data coming in, and because of that, we are able to come back and flag to you that, aha, 2 of your machines are burning up their CPU, for example, right? And a couple of your machines are under attack from this known bad IP address. Okay, so this all just happened for free, right? There was an attack going on, and now I've been alerted to the fact that these kinds of things are happening. So let me show you an investigation. I'll start with a trivial example, right? So 2 machines are burning up their CPU. So typically, all I want to really do is run the top command on those 2 machines, right? So in this case, I'll click on that, and it'll tell me, aha, it's the Miami and New York servers which are burning up the CPU. Yeah. Notice that it has set the filter to machines with high CPU because it's anticipating that I'm going to go and do a further investigation. Right? So what I'm going to do is run the equivalent of top command. So I basically want all the processes on this machine, but sorted by CPU time, because I'm trying to figure out what's burning up the CPU. Yeah? Can't be too complicated from there. I say go for it. Back comes the answer. And lo and behold, I see that there's 2 processes called stress on this machine, which have jumped to the top in terms of how much CPU time that they're using. Yeah. Here's the user time. You can see that it's already multiple orders of magnitude more than normal processes. Yeah. So very quick way to find out what might be going on in your environment. Yeah. So that's a trivial sort of query. Show me all the processes sorted by user time, and now you know who's burning up the CPU, right? And that's easy enough. Yeah. Now we'll do a deeper example, right? So here's basically an alert that says I'm being accessed by a bad IP address. So now I might have questions. So, well, is it still an inbound attack? Or have they already broken in? Have they already installed something on my machine? Have they already started exfiltrating data? What's going on with this? Yeah. So once again, I can go back to my investigate panel and start my query, right? So turns out osquery has a nice table called process open socket. So it is capable of tracking every single open socket in the environment, right? So every single socket on every machine is all being collected in the database, right? So all I have to do is grok through that database and look for this particular bad IP address, right? So I'm going to say go for it. I forgot to clear my filter. So I'm going to clear my filter so that I ask the question of all of my machines, right? Not just the machines with high CPU. So I say go for it, and boy, demo gods are not with me today. It's coming back with empty. All right, let me see what's happening here. Any guess what might be going wrong? You think I got the IP address wrong? 54.165.17.209. 54.165.17.209. Looked right to me. Look right? Try it one more time. 3rd time's a charm, right? Nope. All right, let's go back, check here what's going on. Yeah, so see what's happened? Yeah, it's no longer connected. The attack happened in the past, right? And it's no longer connected. So, well, that's going to happen in the real world too, right? Attacks are going to happen at 2 in the morning. By the time any kind of incident response takes place, time is going to elapse. Besides, these connections, by the way, are open for microseconds at a time. So the chance that you're going to be able to ask a query at exactly the right time is between 0 and null anyway, right? So what good is all of this stuff if you can't use it for an investigation? That's where Att&ck's historical store comes into play, right? So we have recorded all this information in the historical store, right? So now all you have to do is take the same old query, point it at our historical store, and say go for it, and voila. Here you go. Here you have the answer. Yeah. So here's the full record of these connections being made by these particular machines, right? You can see here's the remote address, and you have the full record and so on and so forth of these machines, right? Now, of course, from an investigative purpose, right, the main thing is who opened this connection. Well, the only field that's answering that question is this process ID. Well, this process with this process ID opened this connection. Now comes in another problem with storing osquery data, right? Well, process IDs are not unique across time. You reboot a machine, you could get the same process ID, but I've stored all this data in my database. So yes, I can look this process ID up in the processes table, right? but then I'm going to get matches with a process from 2 years ago that happened to have the same process ID, right? So that's not going to do me a fat lot of good. So that's where Att&ck has done a lot of investment, right? So I can still do this kind of a join. I can say, well, take a look at the process ID from the open sockets table, look it up in the processes table for me. The operation's called a SQL join, right? But Att&ck is smart enough to understand that there is semantics associated with these tables, right? Even though these are just normal SQL database tables, there's a semantic table, a semantic associated with it. It makes no sense to join on the PID if the process was not active at the time that the socket was created. So we take care of all of that windowing for you, and this join will actually do what you expect it to do. So when I go back and do the query, again, also notice that it's a massive amount of data that comes in, about 110 megabytes of data per endpoint per day for us. Yeah, but the query, you can see the speed with which it sort of responded. Yeah, so this is going against a fairly large database. It is able to respond to that kind of a speed. Yeah, so now it's netcat. Oh, geez, you know, reverse shell. Oh my gosh, data going out, something going bad, right? So now I want to know something about users. What user account was used to set up this particular process and so on, because that'll give me some information about what access this attacker had to what files in my environment, right? So now I can do the join with the user table. So the point of all of this being that Att&ck has recorded enough information to recreate the full state of the machine at all points of time. Yeah, so we have users, we have files, we have, or I should say file opens, socket opens, what amount of I/O was going on, not necessarily the bytes that were sent, but what amount, and so on and so forth. So you can practically recreate the full state of the machine at all points of time. So if you're somebody like Equifax and you're really trying to figure out what was going on back in May of 2017 when exactly. If you had something like Att&ck, you would be able to replay your server environment. Yeah. Once again, as I mentioned, the reason people are going towards solutions like osquery and so on, in the cloud, this becomes completely necessary. In the cloud, by the time your incident response comes along, the machines themselves have gone, because if nothing else, cloud machines are not ever upgraded, they're just deleted and recreated, right? That's how you update your cloud and so on and so forth. Not to mention that many machines, VMs, are spun up based on load, spun down when the load goes away. So if an incident happened during that time, you know, by the time you get around to responding, the machines themselves are gone. There's nothing left to investigate, yeah? So unless you have a solution like osquery and Att&ck built in, you're not going to be able to solve critical security controls like incident investigation, right, and so on and so forth. So if you look at many compliance regimes, they require that you have an incident responses team and system in place, a process in place. If you can't even physically do it, how are you going to prove that? So that's why you need something like this. Compliance is another area which is exactly the same thing, right? So you're running your cloud, it's going up and down, very dynamic, completely optimized, yeah? Docker containers are even better. They only stay around for minutes at a time and so on and so forth. And then your auditor comes along every 3 months and says, great, let's look at all the VMs you were running, all the containers you were running to see if they were compliant. Well, by the time the auditor comes along, they're gone. They're all gone, right? There's nothing to check anymore, yeah? So luckily, if you have something like Att&ck, then all of that data is available. All the machines that were spun up are actually in our database. And now we have built-in compliance reports that come along and you can pull. So regardless of whether the machine is here or not, I can actually pull a compliance report from back in May or something like that, and show you the compliance status of that, right? So we have a whole bunch of compliance reports built into the box. I'll show you CIS benchmark. Familiar with CIS benchmarks? So CIS stands for Center for Internet Security. It's, again, another government agency. They're important for 2 reasons. One is they're popular just by themselves. They basically have a set of hardening rules that they have published across all the platforms and so on and so forth, yeah? The other reason they're important is they're actually components of other compliance regimes as well, yeah? So as an example, section 3.2 talks about, is your network properly, or is your network parameters properly configured, right? And it has checks that, you sometimes have to thank the government for thinking of these kinds of things, yeah? So for example, the first check is ensure source routing of packets has been disabled. Now, what is source routing of packets? Well, that turns out it's an ancient feature of TCP. It was built when routers were either absent or basic routers were not very smart to begin with, yeah? So this feature was added way back in the day, right, to allow the sender of a TCP packet to indicate how the packet should be routed across the internet. Yeah. These days, nobody remembers this feature. It's not necessary to remember them, except for all the bad guys. They know about this feature, and they use it to do things like tell your web front-end server saying, yeah, ignore all your IP tables rules. Trust me, route this packet to your backend database. Okay. Not a good idea, right? So you want to turn that feature off, right? Now, I never heard of this feature before until I read this, right? And the way you turn this feature off is by taking these two parameters, you know, net.ipv4 conf all except source route and default except source route. You set it to 0 in syscontrol.conf, right? Now, this is supposed to be in hardened environment, so you're supposed to be able to do these kinds of checks, yeah? Luckily for you, these reports come built in with, and for me, I guess, yeah, built in with Att&ck. Att&ck has all of this data parsed out from all of your configuration files, yeah? And you can see that in this particular case, my default VMs on Azure, they actually all failed this particular check, and the reason they failed the check was because one of the parameters was set to 1, yeah? So as opposed to both being set to 0, okay? So you can do compliance reporting out of the box as well, yeah? So this is the kind of a solution that Att&ck is really all about, right? So you take an environment that has Macs, that has your cloud, that has Windows. By the way, I can show you about Windows stuff as well. We actually have a full parity with Windows across all of this data. So all of these features work across Windows, Mac, Linux, and so on. Yeah. So this is where sort of the value that we are bringing to the table lies. Yeah. So it's all about intrusion detection, threat investigation, compliance, vuln management, and file integrity monitoring. Yeah. Questions, thoughts?
Is osquery that is connecting back to your backend?
Yes. osquery.
Your own version of osquery, or is
Nope. It's well, we kind of do in the sense that you saw me download it from my account as opposed to the purely from GitHub itself. But the binary is identical. Everything we do on osquery, we contributed right back to the community. Although sometimes these days, some of the things we have added, the community has come back and said, we don't want it in the core, you want to put it in as an extension. But either way, everything is available as open source one way or the other. Yeah. And there's no other process, just osquery and so on. Other questions, thoughts? All right. So there you have it. Hopefully this was useful. And drop by our booth if you want to schedule a longer demo. Yeah. All right. Thank you.